My ECE class summary. The basics. So in this screencast presentation, I'm going to go over the class information, relevance to my major, the catapult project we did, small course bot that we did, the Arduino bot that we did, and my overall feelings of the course. So first on, we're going to go with the class information. Early on in the class, we assigned our own groups based on what our major was to be, along with some expectations that the class would be. So what that means is, within like the first week of class, David, he kind of brought in like a little paper, like a sheet, and we each individually kind of check boxed, what our major or our field would be for the class, or whether in engineering was. So it would help the future of the class. We also learned that we would basically be our own teacher, and we would decide if our work would be, or what we, if our work or what we did would be good enough. So basically, what that means is that it's kind of more of a student-centered learning, and what that really means is that you as a student are to be expected to do your work, but only you can decide if your work was good enough, or if you needed to put more work in, or how much work you put in. That's basically what that means. We also early on modeled out what grade we would expect to get and that we would attempt to pursue. And the reason for that is, since we're only referring to ourselves to kind of teach ourselves in the class, or kind of essentially, that we kind of expect or we know what to expect with our grade would be. And pursuing the grade that you want is kind of ideal in this kind of environment situation that you're being a student-centered learning. And the relevance to my major was mechanical engineering. So going back to when we filled out the little paper for our little fields of engineering, I had selected mechanical engineering, and thus everybody on my table did as well. So this is why our group was formed. And going into the first project, which was the catapult project, essentially this project was called Soak to Teach, and the whole goal was to get David, or hit David, with a water balloon that was launched from our catapult, and it was between 20 to 30. And going into the project, we came up with some ideas, we sketched out some examples, and in the class, everybody kind of did this, and we had submitted them, or we had put them on the walls, and everybody kind of voted for their favorite and whatnot. So everybody pretty much knew what they were doing going into the whole project week that we had started doing the construction. And these are some of the early pictures of the construction. So as you can see, it's in the top right corner we have the frame of the base of the catapult, and then we have on the left side, this is where the arm would connect to, and it was kind of the latch essentially, and the two little plywoods at the bottom are from where we would put the arms up, and that would be where we connected our string and our launching mechanism to. This is a picture zoomed in as well. On the left side, you can see when we had first started building or attaching our locking mechanism into our base, and on the right side is where you can see where we started connecting all the arms and everything to the base as well. And on the left side, you can see from when we started our project early on compared to the right side is when it was fully done. As you can see, everything is connected, and our launching mechanism was zip tied, as you can see on the right picture. That we connected that and just wrapped it around once, and that was our launching, or that was our launching mechanism. And if you look closely underneath the little green webbing, you can see a metal piece. And what we did with that is we had a rod that we locked into place with that, and we had each dial dialed in for, it was 22, 24, 26, 28, and so on. And wherever David was standing, we kind of measured it out, and we tried to get it into that specific range from the lock. And overall, project 1, feelings about how we did. I think we did pretty good. We were the closest to hitting him out of the groups in our class, and unfortunately nobody actually hit him. but we were the closest of hitting him. We were within the same range. We were just off to the side, sadly. Some problems. We didn't have really many problems with the whole construction. We kind of knew what we were doing because we had sketched this out, the examples. So we followed our sketch pretty much exactly, and we didn't really have any problems, honestly. I would say the biggest problem was cutting the wood, and that was just because like the saw that we had was like cutting off like the actual like holder for the wood. We were just like cutting into that, but other than that, construction wasn't really a problem. Going into the next project, which was the course bot project, we had a pretty good feeling. We worked well together. Everybody did what they were needed to. Nobody really slacked off. Yeah, nobody really had any, or we didn't have any problems with each other. So going into the next project, we felt pretty comfortable with the group that we had. And obviously, at the start of the next project, we could change groups, but we ultimately decided not to. And this goes into project 2, which was the course bot. So basically, this one, I can't exactly remember the name of this project, but essentially we had to get our bot, we had to build it together, or put it together, and we had to get it essentially, or get it to follow a figure 8, and we had to do that twice, and we had to time it. And the quickest around the course would win. And early on, when we first got handed the packet, we opened the pack and we scanned it and we went online to look at the pieces, and we referred to the book as well, so we knew what each piece was named, what it did, its function, and also that to make sure that we had every piece, that we weren't missing anything. And going on to construction, these were early pictures, so you can kind of see our pieces lying around. You can see our motors, the battery pack. You can see like the gears, the wheels. You can see like everything from the whole kit is just lying there. On the left side, you can kind of see when it's pretty much all put together, and on the right side is where we're pretty much everything except for the battery pack and the wiring and like the LEDs and whatnot. But it's like the base of it was on the right side, and kind of it finishes on the left side. There's kind of two different views you can get. So you can kind of get like the above screen with, you can see all of its like labels and everything, and on the right side you can kind of see like the length of it and how much like little details is really put into it. And this one you can see on the left and the right, they're pretty much identical. Like the only difference is that on the right side it is lit up and on the left side it is not. And what this means is that the power's on and the resistors and the potentiometers and everything's working. But on the right side, since they're both on, it's because the potentiometers are linked into each other and they're powered right. But on the left, you can see the potentiometers are kind of going outwards, but on the right side, you can see they're going like inwards. And the reason for that is because you needed them to kind of point at each other and not to point away from each other, because then they wouldn't pick up and read anything, and you'd be just going in circles and circles and circles, or one wheel just wouldn't work at all. And that was a problem that we did have. This is another pictures of the side, but as you can see, there's a little bit of a difference from when this picture on the right side is, and that is that the wheels are bigger, and we also added like an external, like another like extra wheel on the bottom of it, because we were getting style points as well. So we wanted to try to make it look a little bit better as well, and to kind of make a difference compared to ours and everybody else's bot. So it's more like easy to identify as our bot. And ultimately, we also put in a Lego guy on the top, and that was also for style points as well. But as you can see, you can still see like the where we put the original like external wheel in the front, but as you can see, it's like barely on. So originally we were going to have this like the third wheel on the front to keep it elevated, but we decided not to in our final test, and it actually worked out even better than when we did have the wheel. So that was pretty good. How we did, once again, we were the closest in our class, or we were the fastest in our class. So on the previous project, we were the closest to hitting him. On this one, we were the fastest around the course in our class, and at the time, we were the fastest between our class and the class before us. I'm not sure about the class after us because I did not check up on that, but being that we were the fastest, in our class and the class before us, we can pretty much kind of understand the feeling, or get the feeling that we were the fastest overall. Problems, I I don't think we had really many problems like with the actual construction. I think that was pretty easy. We got a couple like potentiometer problems, but like the construction itself worked. It was just like getting all the small little details to work perfectly was the problem. And we did have a piece that broke on us, so we got that replaced as well. Um, but also another problem we had, I guess, is like not really deal with the construction, but more of like with the thing itself and how we wanted to present it. We didn't really know what like modifications we can do, so that's why we only did the bigger wheels and the front wheel. And the reason for that was is because the bigger wheels means more traction. More traction means you're covering more distance over time. And the front wheel, we just decided for style points, but it did slow us down, so we ended up taking that. But we kept the bigger wheels as well. And our feelings for the next project, this project was solid. Like we didn't have really any problems with the group. Everybody did their work even more than the previous one. Um, so I would say that we were pretty much ready and confident in our next project, and that was the Arduino bot. What this was is we constructed a small little, or it's not little, it's bigger than this one by a extremely amount, almost twice the size of this one. But uh, we constructed it, and we would program it as well. We would put in our own code, and this one was to travel like in the form of a P and a V for Paradise Valley, which is our school. And yeah, it was just those two things. It was to build and to program. And this is construction. Oh, but before going into construction, this is like the small little books. So this is to learn how to do everything, like the basics and whatnot. So on the left side you can see the LED is off, and on the right side you can see it's on. And what this project was is just whatever button you click, it activates as like a circuit, and it starts the light or the LED. And on the left side you can see that's right before we touch it, and on the right side is after we touch it, and the light lights up. So we did that perfectly. On the left side you can see pretty much the whole construction itself was done except for the like putting the chip, like the Arduino like chip itself on it, and also the wiring. And the batteries were missing as well, obviously, but the batteries were missing on both pictures. And on the right side you can see kind of what we did to like form everything on there. Originally you were supposed to like have the little like motor shield, which is the Arduino piece, the blue circuit board, and you were originally supposed to have it kind of like toward, like pointed in, but it was kind of hard to like plug in the motor shield into the computer like with the cord. So we kind of just like rotated it a little bit and kind of taped it down, and kind of did it like our own makeshift way to make sure it was easy for us. The overall feelings about Project 3, how we did, I think we did pretty good. We got the PV done. We coded everything pretty good. The problems we had, the soldering was backwards. The coding was terrible. Like we struggled with that. We basically spent 2 classes, learning how to code itself. The book stuff was pretty good. We didn't really have any problems with the book stuff. But yeah, that coding was tough. But we got it done. We got the PV done. So we did pretty good on that one, I feel like. The feelings about moving on to the next project, which is the next semester class. We're actually going to be working with this like bot, not specifically, but like the bots that we have already done. We're going to be using these for the next semester's class, and we're going to be kind of expanding on it as well. And going into that, I'm not. It's going to be rough. Depending on like how this one was, it's going to be, it's going to take some time for sure. This next project, specifically on the coding. The coding itself was really time consuming and stressful. Feelings on the course. I feel pretty good about the course. How it's helped. I mean, it's helped me in a lot. I've learned a lot of things from from the coding that we did, from the simple constructions that we did, to soldering, like the small little details. We've learned a lot over the whole course of this course. My effort. I think I did pretty good in my effort. I mean, yeah, there was times where I kind of like lost my motivation, my effort, like specifically on this coding. Like I just wanted to give up. But early on in the class, my effort was pretty solid. I feel like my attendance, I only missed 1 day, and other than that, I was there all the time. I mean, my attendance I don't think was a problem. And the future, I feel like the future of just like this course specifically is just it's gonna keep helping me. like as I go on and whatnot. I mean, it's helped me so much this far, and this is only the beginning. I can't imagine, towards the end and how it'll